For the video retake, we're going to go through 2 examples, and then we're going to graph those on Desmos. For this one here, I want to just look at the 4 steps to the graphing shortcut. Before we look at the shortcut, I want to remember that we are always comparing our equation back to the standard absolute value of x function. Always going back to the standard function. So graphing up or down is the thing outside the parentheses, or the value of k. We look at that first. Left or right is the value of h that's inside the parentheses. And we're always going to do the opposite of whatever that value is, because we're creating a 0 in the parentheses. And then finally, the value out front, a, right here, determines if we are growing faster or slower, and if we're flipping the function. So let's get started. For this one here, the first step is we want to look at the number outside of the parentheses. That's right here as -3. -3 means that our vertex is going to be going down 3 from the standard function. The left or right is determined by the number inside of the parentheses, which is +2. I know that -2 plus 2 creates a 0, so I'm going left 2 from the standard vertex. The good news, outside of the parentheses here is a 1, or nothing, which means that we do not flip and we have a normal growth rate. So let's graph the original function first. I always like to do that if I have the option, with a slope of 1 in both directions. And now I want to go down 3, 1, 2, 3, and left 2 from the standard starting point. No flip and a normal growth rate means that my growth rate should look exactly like what I graphed originally. And that is my new graph. I have that done, and it took me about a minute to get all of that together. Now let's see if we graphed it correctly by graphing this on Desmos. So, show desktop. So here we're going to do f of x equals, and we're going to do absolute value, x plus 2 minus 3. And here's our new equation. It shows our vertex as -2, comma, -3, and it has a normal growth rate going up. So it looks like we graphed it correctly. Let's do one more. We have -3 times the parentheses of absolute value of x minus 4 at the end. So let's do our 4 steps again. First step is, are we going up or down? That's the thing outside the parentheses but behind, which is -4, which means our vertex is going to go down 4. Inside the parentheses determines if we're going left or right. There is nothing inside the parentheses with x, therefore this is left or right 0, so we can just say normal. Now we have to look at the value in front of the parentheses, which is -3. Negative means we do flip, so yes, and our growth rate is 3 times as fast. So we have all the information we need to do the graphing shortcut, but let's graph the original function first. It's always going to save us time in the end. Okay. And now let's graph our new function with our new graphing shortcut. So we want to go down 4 from the original vertex, but left or right 0. So right here. The function does flip, so we're going down, and the growth rate is 3 times as fast, which means if I plug in a 1, instead of going up 1, I should go down 3, because 3 times as fast. So if I plug in a 2, instead of going up 2, I should go down 6. And here should be our new function. Of course, I want to check this on Desmos to see if I'm on the right track. We have -3, absolute value of x minus 4. So we have -3 times the absolute value of x minus 4. Looks like our vertex is right. If I plugged in a 1, it looks like we got -7, which is what we had. And if we plug in a 2, we still hit -10, which is what we had. So that means we have the right graph. As always, if you have any questions, please let me know.